Hey there, science fans! Today, we're diving into the exciting world of computer programming. Specifically, we're exploring a powerful approach called declarative programming. In traditional programming, which we call imperative or procedural, you tell the computer exactly to do something. It's like giving someone step-by-step directions to your house, but in declarative programming, you focus on you want to achieve, not the nitty-gritty details of how to get there. Imagine telling your computer, find me all the prime numbers between 1 and 100. You're stating your desired outcome, and the computer figures out the best way to make it happen. This shift from how to what is a game changer. Declarative programming excels at solving problems involving logic, relationships, and patterns. It's like having a super smart assistant who can handle complex tasks based on your high-level instructions. Now, let's meet one of the coolest declarative programming languages out there. Prolog! Prolog, short for programming in logic, is a programming language designed for, you guessed it, logic and reasoning. It's used in artificial intelligence, expert systems, natural language processing, and more. Imagine building a program to diagnose diseases based on symptoms. In Prolog, you'd describe the relationships between symptoms and diseases using logical rules. Then you could ask the program, given these symptoms, what's the likely diagnosis? Prolog shines in situations where you need to express complex relationships and make deductions based on those relationships. It's like having a detective partner who can crack even the toughest cases using logic and deduction. Let's take a peek under the hood and see how Prolog works its magic. Prolog programs are built using three fundamental elements: facts, rules, and queries. Facts are simple statements about the world. For example, cat, Tom, dog, Fido. These facts tell us that Tom is a cat and Fido is a dog. Rules, on the other hand, express relationships between facts. For instance, likes X, Y, cat X, fish Y. This rule says X likes Y if X is a cat and Y is a fish. Notice how we use variables X and Y to represent any cat or fish. Finally, queries are questions we ask. Prolog. For example, likes Tom tuna. This query asks, does Tom like tuna? Prolog would respond with yes, because we know Tom is a cat and tuna is a fish, and our rule states that cats like fish. Section 4. Prolog's secret weapon, backtracking to find solutions. One of Prolog's coolest features is its ability to find solutions through a process called backtracking. Think of it like navigating a maze. Prolog starts at the beginning and tries different paths. If it hits a dead end, it backtracks to the last decision point and tries a different route. This backtracking mechanism allows Prolog to explore all possible solutions systematically. It's like having a tireless assistant who checks every nook and cranny until they find what you're looking for. Section 5, your first Prolog program, a step-by-step guide. Ready to write your first Prolog program? Let's create a simple program to determine if someone is eligible to vote. First, open a text editor and save the file as. Next, define a fact, Prolog age, John 25. This fact states that John is 25 years old. Then define a rule, Prolog can vote X, age X, Y, Y = 18. This rule says X can vote if X's age is Y, and Y is greater than or equal to 18. Save the file and open a Prolog interpreter. Load your program by typing Prolog consult voting.el. Now ask a query, Prolog can vote John. Prolog will respond with yes, because John is 25 years old, which is greater than 18. Congratulations, you've written your first Prolog's program. You've seen how to define facts and rules and use them to answer queries. Now you're well on your way to becoming a Prolog pro. This is just the tip of the iceberg when it comes to Prolog's capabilities. I encourage you to explore further, experiment, and discover the power of declarative programming with Prolog.